Welcome to Homework Lib.
Hi, so over here we're going to provide structures for C4H10O. We're going to have 7 structural isomers. So first of all, we can identify this as having an OH group at some point of the structure because we're going to have more than 2M plus 2 substituents over here and an oxygen atom. So to provide 7 structural isomers, let's begin with 2, 3, 4 carbon atoms and the OH over here. Another option would be having the OH now on this position. And since the molecule is going to be symmetric, those are the only 2 options of the direct alcohol that we're going to be able to have. Another option is going to be to think about ramifications. So now let's say that we have the CH3 group on this position, and now, whoops, 1, 2, 3, 4 carbon atoms, and we are going to attach now an OH over here. Notice that any other possible combination is going to just generate the same compound or one of the options that we have already wrote down. Another potential option is going to be having a different ether compound. So let's begin with C3 over here and an oxygen now on this position. 1, 2, 3, 4 carbon atoms, 1 oxygen, and you can count 3, 6, 8, and 10 hydrogen atoms. So the ether is going to be also a possible option over here. Another ether that we can generate is going to be the symmetric version of this, which is going to be the ethyl ether. And another possibility that we can think about is having ramifications on our ether. So 1, 2, 3 carbon atoms, oxygen, CH3, for example. And a last one, let's verify that if this is true. And let's think about the last one that I'm missing. I'm missing one alcohol isomer, which is going to be the following compound with the OH over here. And those are all of them. And now let's look for the next compound. We are looking for 8 structural isomers. So in this case, we're going to be looking at different amines. In this case, the first one is going to be with 4 carbon atoms and the amine at the end, 1, 2, 3, 4 carbon atoms and NH2. Next up, we can look at the amine with a ramification over here and the NH2 now on this position. So 1, 2, 3, 4 carbon atoms. Now we can think about the amine being next to the ramification now on this position. We can also consider the terbutyl version and the NH2 over here. Those are 4 amines that we're going to have. And now let's look at different secondary amines that we can generate. So we can say, first of all, an ethyl ethanamine, which would be 2 ethyl groups connected to the amine group over here, an H. As such, uh, 3. We can also have another secondary amine, but now with 3 carbon atoms on one side and a single carbon atom on the other. Actually, it should go like this. Another secondary amine would be having 3 carbon atoms attached to our NH group and attach this to the CH3. And the last one would be having a tertiary amine with 2 methyl groups and an ethyl group on this position. And with that, we have finished with the 8 structural isomers for this compound.